In this video, I will guide you through a one-way ANOVA test using a 5-step hypothesis testing procedure. Continuing our exploration of one-way ANOVA hypothesis testing, this part delves into the statistical test itself, analyzing group means at a predetermined significance level. To fully grasp this video, it's recommended to watch part 1 of the series on one-way ANOVA hypothesis testing. Following up on our creation of a one-way ANOVA table in part 1 for the plant growth lamp effects case study, this part will delve into analyzing the results to test the hypothesis at a predetermined significance level of 0.05. A 5-step hypothesis testing procedure involves the formulation of null and alternative hypotheses. This step builds the foundation of the test. The null hypothesis states there's no significant difference between the population means, while the alternative hypothesis addresses the research question, suggesting at least one population mean differs significantly. Before performing the test, it's crucial to ensure that the data satisfies certain statistical assumptions. These assumptions include normality of data, independence of observations, and homogeneity of variances. And once assumptions are confirmed, we'll use the computed test statistic and the p-value from the ANOVA table. Then, we will use the p-value approach to make a decision about the null hypothesis. And in the final step, we will conclude the summary of the hypothesis test in the context of the study. Let's start with the first step, where the null hypothesis states no significant difference in the population mean seedling heights due to the lamp types, and the alternative hypothesis tests the claim that there is a significant difference in population mean seedling heights due to the lamp types. In statistical terms, under the null hypothesis, all the population means are equal where mu is the population mean seedling height. And the alternative hypothesis states that at least one population mean is different. Now, moving on to the second step, we can visually verify the normality and homogeneity of variances in the sample data using the box plots. The side-by-side box plots are drawn in RStudio using the following code. The median lines in each box plot are close to the center, suggesting that the samples are likely normally distributed with no outliers. And since it is not given in the problem statement, we can assume that the pots are assigned randomly to each lamp type, suggesting that the observations are independent of each other. Now, considering all the assumptions are satisfied, we will use the F statistic and the corresponding p-value from the ANOVA table, created in part 1 of this series. The F statistic is 76.664. And the p-value is less than 0.05. In the fourth step, the p-value approach is used to make decision about the null hypothesis. In this case, the p-value is less than the predefined significance level of 0.05, which means we can reject the null hypothesis at a 5% significance level. Now, in the fifth and final step, we will conclude the summary of the hypothesis test. Since the null hypothesis is rejected at a 5% significant level, there is sufficient evidence to conclude that the difference in population mean seedling heights due to the lamp types is statistically significant.